Welcome back to one of my videos on momentum. This video we're going to look at a question from an NSC exam that involves momentum and impulse. Momentum is by definition the product of an object's mass and velocity. So it's a quantity of motion. Impulse is by definition the product of the net force acting on an object and the time span or the duration of the net force acting on the object. So it's the product of the net force on an object and the time during which this net force acts. And this quantity, impulse, will cause a change in momentum of the object. So a net force acting on an object accelerates the object, so the speed of the or the velocity of the object will change, and therefore there will be a change in momentum. If I can take you back to Newton's second law, if net is ma delta t will be equal to m times vf minus vi. So an acceleration means that there is a change in velocity, and the mass is, sorry, I'm on a different trajectory here. So mass is a common factor there, just to show you that the acceleration times the time of the collision equals the change in velocity, where acceleration is by definition the rate of change in velocity. And on the data sheet this is hidden in the equation Vf equals Vi plus a delta t. But that is on the sideline now. I just try to show you that the net force, the product of the net force and the time that the net force acts on the object, will cause a change in momentum of the object. So we've got two trolleys here, A and B, of masses 500 grams and 750 grams. Now that's illegal to use the grams. They should use kilograms. So A has a mass of 0.5 kilograms, and there's a spring between the two trolleys. B has a mass of 0.75 kilograms, and initially their initial velocity is 0 meters per second because they are at rest. There is a compressed spring between them. When the spring is released, trolley A moves at a constant velocity of 2.5 meters per second. In which direction? To the left. So Vf, that's the velocity after the explosion, which is considered as a collision, is 2.5 meters per second. The question is, in which direction will trolley B move? Explain your answer. So for 7.1, the momentum, the change in the momentum of A would be in that direction, or the force that the trolley that the spring exerts on the trolley is in that direction. The same spring will exert a force on trolley B to the right. Now the total initial momentum of the trolleys is 0 kilograms meters per second because they are stationary before. Now this total initial momentum must be equal to the total final momentum. So 0 equals the momentum use the momentum of trolley A, so it's its mass times its final velocity, plus the mass of B times its final velocity. Sorry for swapping the F and the A, it's final velocity of A. If we do our mathematics correctly here, the mass of A times the final velocity of A will be negative the mass of B times the final velocity of B. Now mass is a scalar quantity, and the negative here indicates that this momentum would be opposite in direction to that momentum. So it's all about the negative. When we work with vector quantities, a negative implies the opposite direction. So basically, I can explain my answer by saying that trolley B would have a negative momentum compared to trolley A because it's moving in the opposite direction. So its velocity will also be in the opposite direction. The momentum of B will be equal in magnitude but opposite in direction to the momentum of A. It's also an application of Newton's third law, where the spring is exerting a force on A to the left, and that same spring exerts an equal force on B to the right. Right, question 7.2. Calculate the magnitude of the velocity of trolley B. To be able to do that, we need to use the principle of conservation of momentum. Now we already know that the mass of A times its final velocity is negative the mass of B times its final velocity. So we're going to use what we deduced here in question 7.1. Mass of A is 0.5, final velocity of A is 2.5, minus the mass of B is 0.75, and it's its final velocity that we need to calculate. So V final B will be, let me just get my calculator right under the camera here. It's the 0.5 times 2.5 divided by the negative 0.75, and that gives us an answer of negative 1.67 meters per second. Now they asked us for the magnitude of the velocity, and this negative is related to the direction, which means to the right. So the magnitude is 1.67 meters per second. Let's move on. They say this trolley, in question 7.3, they say that this trolley A collides with the wall. So it moves at a constant velocity, it hits the wall, and the wall exerts a force, which is a net force because it will change the direction and therefore the acceleration of the trolley. Trolley A continues to move to the left until it hits a wall at a velocity of 2.5 meters per second. So remember, it says there's no friction, So this thing moves at a constant velocity until it hits the wall. The wall exerts a force, a net force of 21.5 newtons on trolley A over a period of 0.5 seconds. So my thinking is that it will be an impulse related question, this one. Continue to ignore the effects of friction. So we have, what is the magnitude of the net force exerted by the trolley A on the wall? And once again they use the word magnitude. Now here, if the wall exerts a force of 21.5 newtons on the trolley, according to Newton's third law, the trolley will exert a force of 21.5 newtons on the wall. So the answer is 21.5 newtons. And it's an application of Newton's third law. The two forces are action, reaction forces, or we could say it is an action-reaction force pair, and therefore they must be equal in magnitude, opposite in direction. Right, let's go to the next question. The next question, 7.3.2, says that we need to calculate the velocity of A after colliding with the wall. Now we've got the net force that is exerted on the trolley. We've got the time of the impact, and we know that this is equal to the change in momentum, so it's mvf minus mvi. The net force is 21.5 newtons to the right, and the time is 0.1 seconds. The mass of the trolley is 0.5 kilograms. The final velocity is what we want to calculate, minus. Now here we need to go back to our diagram, and because we have vector quantities, the force is to the right and the initial velocity with which it hits the wall is to the left. So we need to make a decision here. I'm going to choose the net force direction to the right as positive, then this initial velocity with which it hits the wall as negative. So I must remember that when I do my substitution into this equation. So it's minus 0.5 times minus 2.5. Right? So my final velocity, the velocity of trolley A, would be 21.5 times 0.1, that gives me 2.15. This answer here has a positive value, so I'm going to subtract it from my 2.15. So it's minus 0.5 times 2.5. Now that will give us 0.5 times VF. So VF, I need to get this answer, it's 0.9, and I have to divide that by 0.5. and we get, sorry, it's a negative 0.9, negative. No wait, it is positive because I chose to the right as positive, and this thing will move away from the wall, so it's perfectly correct. Divided by 0.5, and I get a 1.8 meters per second, and that means it's a velocity of 1.8 meters per second towards the right or away from the wall. Good to go. The last question in this question says that an identical trolley C of the same mass and velocity as trolley A collides with the same wall. The wall exerts a net force on trolley C in an increased contact time compared with the contact time of trolley A. Now, if the contact time is increased, the net force acting on the object will decrease, but the impulse, the change in the momentum of trolley C would be exactly the same as the change in momentum of trolley A. So they want us to compare the impulse of trolley C to that of trolley A, and my option is it will stay the same. So for question 7.3.3 I choose it stays the same. Now we have to answer this horrible question. We have to give a reason for our answer. So if the mass of the trolleys, if the masses and the initial velocities of C and A is the same, it means that the change in momentum of C is equal to the change in the momentum of A. Because they have equal masses and they have equal velocities at the start, their changes in momentum will be the same. So it means that the net force is inversely proportional to the delta T. So if delta T for trolley C is longer, then 1 over delta T, which means the net force will be less. So the F net on C will be less. And because impulse is equal to the change in momentum, if the impulse is the same, the change in momentum will be the same. Sorry, if the change in momentum is the same, the impulse will be the same. Thank you for watching my videos. I hope they help you in preparing for the upcoming final exams.